Hello. Today we will understand total internal reflection. So what is total internal reflection? When light travels from an optically denser medium to an optically rarer medium, it bends away from the normal. As we go on increasing the angle of incidence, the angle of refraction will continually increase. And at one point it will become parallel to the boundary of the surface. After that, if we increase the critical angle, the whole of the light will get reflected and without any getting refracted. That is total internal reflection. We have made this apparatus by which we will study total internal reflection. We will find it experimentally by using this apparatus and putting light here and seeing the critical angle, and we will also verify it by using Snell's law, which is sine of angle of incidence upon sine of angle of refraction equals the refractive index of the rarer medium upon refractive of the first. So we will find the critical angle of water. By using Snell's law, we have found that the critical angle of water is around 48.6 degrees. So let us try it experimentally. Here you can see there is no total internal reflection and the ray is getting completely refracted. And now you can see at around 48 degrees here in the scale, around 48 degrees, there is the ray is parallel to the surface. And now it will after that angle it will get reflected. See. We will find the critical angle of isopropyl alcohol, which is C3H7OH. So here I have filled isopropyl alcohol or some sanitizer into this petri dish. By using Snell's law, we have found that the critical angle is around 46.88 degrees. So let us see. Here you can see the ray is getting refracted. If you look at this angle, there is total internal reflection. And now around 46 degrees here. This is the critical angle. You can see the ray is parallel to the boundary. The ray will get total internally reflected. You can see this clearly. So we find the critical angle of oil. The refractive index of mustard oil is 1.46, approximately 1.46. So we have used mustard oil here. We have found by using Snell's law that the critical angle is approximately 43 degrees. So let's see. So here I'll start putting the ray like this. And at this angle, you can see that the light ray is coming parallel to the boundary. And after that angle, you can see that the light is getting reflected like this. Thank you.